Good afternoon, everyone. Thank you for being here. I know it's getting late in the day and the week, so you've been absorbing a lot of great information, and hopefully this might be your last session of the week or of the day, so you can go enjoy some drinks and dinner with your friends. I'm going to surely do this after this presentation. My name is Evan Cherney, and I'm part of the customer analytics team at Unilever. And today I have the distinct pleasure to present to you our journey through Databricks DLT and how we've reimagined our data foundation to drive scalability, operational efficiencies, and real-time analytics. But before I start, I just want to take a break to thank you all for choosing this session. I know there's a lot of other great speakers and sessions going on right now, but you decided to be here with me, so truly thank you. If you don't know what Unilever is, we are one of the world's largest CPG company. We sell about 1 billion products each day. We have a vast portfolio, which includes Dove, Tresemme, Hellmann's, Knorr, which is Best Foods, also, and a lot of other brands. With that said, we'll jump into the agenda for today. We'll start off by talking about why we needed the change and go and transform with Databricks DLT, and then where we started as an organization, talking about our architecture and our data ecosystem, and then go into what we've built, leveraging Databricks and DLT, and finally end with what we've learned and how our outcome has resulted because of this transformation. And I'll try to leave about 5 minutes for Q&A, and if you have questions after the session, I'll stick around so that I can answer them. So I want to start off with grounding us with the why behind this transformation and why we've invested time and resources into migrating to Databricks DLT. So we wanted to modernize our data foundation to empower our customer teams with real-time analytics, scalable AI, and the agility to adapt with the fast pace of retailer and our consumer needs by driving smarter decisions and sustainable business growth. We knew that we could do this through 3 main objectives. We wanted to deliver rapid, trusted insights, which is by having our data delivered more efficiently and meeting our business SLAs. So we wanted to deliver faster error resolution and root cause analysis when our data has bad quality or if there's issues in our source systems. We also wanted to build trust within our data. So we wanted end-to-end data quality and lineage, so we had the transparency and the visibility of our data assets. And we also wanted to have serverless and scalable infrastructure to grow with our business as we grew with our retailer partners and the evolution of data that they started to share with us. Second, we wanted to have next generation capabilities. So as you've been hearing all of this conference about generative AI and mostly agentic AI, we wanted to unlock AI-enabled analytics and take advantage of it for our business growth. We also wanted to have real-time data activation so that our business could have the data more efficiently and quicker so they can meet their goals and identify gaps quickly. We also wanted to have a flexible and adaptable design because, as you've seen, technology goes fast and it's not going to slow down anytime soon. So being able to have an architecture that sets us up to be able to adapt with this change and the technological shifts. And then third, we wanted to lead with purpose. We wanted to build an industry-leading data solution that could help us grow our business more efficiently. We also wanted to experiment, innovate, and activate on these new technologies as we were able to test with them. And then finally, we want to have sustained investment in modernizing our data capabilities because data foundation is at the core of all of our analytical capabilities. We need to be able to have a data foundation that is accurate and reliable to deliver on ML, AI, and dashboarding needs. But setting the vision was just the beginning. To make this real, we had to look at what was holding us back as an organization. So we took a look at our teams and our data flows and our tools, and we found a few core challenges that stuck out to us, and we wanted to identify how we can shift from these major challenges and make sure that we're removing the friction points and to help our teams move faster and smarter. So we wanted to go from lag data and slower error resolution to driving real-time analytics and faster action. We wanted to go from legacy pipelines to agile pipelines that accelerate access to our teams internally and externally. And then lastly, we also wanted to go from fragmented views across our teams to a connected data that helps us uncover growth. We wanted to democratize that data within our organizations. And with removing this helps us grow our business more efficiently. These shifts were essential for everything that followed for this presentation, and it helped us build a platform that could actually deliver on the vision that we had in front of us. And it all starts with our foundation, more specifically our data ecosystem, and talking about what data we have, where it comes from, and how it connects to all of our different platforms and capabilities, and how it powers our insights. So, as most of you know, customer data and the ecosystem can be very complex. For us at Unilever, on the customer team, we deal with a vast variety of data assets. Some include velocity and consumption, geolocation, points of interest, distribution, shopper, which is demographics and psychographics, shipment, and product attribution. And that's just at the surface. There's a lot more data underneath and a lot more that's going to be readily available in the future with the unlock of AI. Anything can become pretty much data assets now. But for our ecosystem, this might seem pretty simple, but underneath the surface, there's a lot more complexity. We manage petabytes of data every day, and we ingest from a diverse amount of source systems that range from internal partners, external vendors, or even third parties. And as AI has shown, there's going to be a lot more data coming through videos, images, social media, so we want to be able to be ready for that. Not only that, the integration of this data into our platforms. We need to make sure that we're connecting this data in a way through natural and engineered connections to help make sure we're driving insights. So it needs to be intuitive, cleaned, and integrated into our applications like dashboards, machine learning, AI, and much more to help us uncover those untapped potential. Not only that, we need to have security on this data. We need to make sure our data is governed and accessible so that the right people have the right access at the right time. Also with timing, as I said, there's a lot of sources that we ingest from. So the frequency can be varied from those source systems. It could be real time, it could be daily, it could be weekly or monthly. It just depends. And also could be streaming or batch. So we need to be able to handle that different frequencies of data that we're receiving. As you can see, this is very complex and deeply layered and dynamic. We need to evolve to be able to handle this complexity within our source, to simplify and also scale for the next generation capabilities. So with that said, we're going to talk through our current architecture and show you what supported our growth over the last few years and why we needed to evolve to meet the new demands of our market. So on the screen here is our older architecture, but I want to take a step back and kind of talk about our evolution of a customer analytics organization over the last decade. It might be similar to a lot of people out in this audience right now. And we started with access databases, we went to Teradata, we used third-party solutioning, our tooling, we've used physical and virtual machines, and then we gradually migrated to the cloud with new front-end capabilities being switched out and on depending on our needs, and also different technological capabilities like Alteryx or Dataiku or other aspects that we've took advantage of. The key theme here, though, is that we kept adapting with the needs of our partners, and we were trying to keep on meeting our demands for insights and grow at the pace of our customers and retailers. But for our most recent setup, as you can see, we leverage Databricks notebooks using PySpark, Spark SQL, and we use that to do ETL transformations, and then we use ADF to orchestrate those transformations. And from there, we use Delta or Parquet, mostly Delta, so that we can incrementally update the data instead of having to do full refreshes. We store that within AWS. For our organization, we use Azure, And to make that accessible through Databricks, we use Hive Metastore so that we can do advanced analytics and apply data science on top of it. But that wasn't just what we needed. We needed to be able to deliver this data to our business partners. So we had to copy this data to Azure SQL data warehouses so that we could connect it efficiently and effectively to Power BI and have those dashboarding needs for our businesses. Also, we copied the data within AWS storage to share our data internally and externally because there was no other mechanisms. We use SFTP, SAS to help share this data across. With that said, there has been some limitations with this architecture. One of them mainly was the limited visibility and data governance. So not being able to see how our data assets were built and having that visibility of what our data assets are built off of for our reports, and then also had high operational overhead. So with the amount of pipelines that we had to manage, it was fragile, and you had to make sure that you had the root cause analysis. So making sure you identified where it was breaking, and then had to update a bunch of different pipelines to make sure the final product for the business was refreshed. And then lastly, there was access barriers, so democratizing this data to our business partners. There wasn't an easy mechanism to share our data across internally and externally for third-party vendors. So it was hard to scale, slow to share, and often required heavy engineering support because we had to create processes to share this data internally or externally. And then we had to manage those processes. It served us well for the time, but it wasn't built for where we wanted to head as an organization. We needed something faster, simpler, and AI ready, which brings us to the new architecture that we wanted to implement. With the rise of AI and the needs of the industry shifting and our partnership with Databricks deepening, it was time to rethink our architecture in a way that could help us build that sustainable growth. So we collaborated with Databricks, grounded in that business purpose and goals that we wanted to achieve. We aligned on what success looked like and what capabilities was needed to support that. The key priorities for us was to simplify our architecture, eliminate engineering redundancies and operational redundancies, and then also reduce the complexity overall. At the center of it, you can see DLT and serverless compute. These were critical for us because we wanted to have a scalable and automated pipelines that helped us manage the infrastructure in the background. We also wanted to use serverless so that we didn't have to manage that compute. As many of you know, Spark jobs are very hard to manage. Depending on the scale of your data or the size of your workloads, you want to make sure that you have the right compute for the right job so you're not wasting money and also time. And we also switched from ADF to workflows just to remove that redundancy of technology and simplify our architecture to bring it in. So we went all in on Databricks, and there was a kind of a point for that. We wanted to have that end-to-end lineage also for our products so that we can see how our data was flowing through our full ecosystem. And then it also helped us simplify our jobs and notebook triggering. And then at the center of it, one of the most important parts was Unity Catalog. We wanted a centralized data governance platform that helped us understand what data we had, where we're sharing it, and the lineage behind it, and an easy way to securely access it and share it across different organizations. And another point we added was adding a SQL endpoint within SQL Data Warehouse and Databricks. And that was helpful because we didn't have to then copy the data from our Databricks workspace or AWS to our Azure SQL Data Warehouse, which was also redundant, and having that data copied over. This helped us have more representable data within our source system because it was directly connected to Unity Catalog. It made our data frictionless and trusted across our platforms. In result, this architecture helped us have a modern but secure and flexible architecture. It empowered our teams to unlock insights and opportunities like we haven't had before and unlock those capabilities like machine learning and AI. So how did we do this, you might be asking? And we did this through DLT was the main component, and that's why you're here at the session. So we'll talk about DLT, but before I do, I kind of want to set the framework of what DLT is. Raise your hand, have you been utilizing DLT or have used it before or know what it is? Awesome. So DLT is a simplified data management ETL framework that uses declarative code to help handle the infrastructure and help you manage your pipelines more efficiently. The main thing that I get out of this is it helps you focus more on your data and less on the data management. For us, on the customer teams, we're building capabilities and platforms, and that was great. We were driving business, but we got stuck in the maintenance of those pipelines, so we wanted a mechanism to help us unlock that untapped potential more and less on the data management side. So the key benefits for us, specifically, it helped us speed up our development process. So instead of having to have our tables and create them and then stitch them together and create all that interdependencies and manage those, it helped us manage that for us. It also helped us reduce the engineering complexity overall. And it had the data quality checks built into it, which was critical for us so that we could help build that trust within our data assets. Another critical part for us was that it supported both batching and streaming. As I talked about earlier, we ingest from a diverse amount of data sources, so it's critical for us to have the capability to ingest both batching and streaming. So now that you know what DLT is, I'll talk about some of the components that we've utilized to help this possible and the key benefits we've noticed. So for us, while we're going through this transformation, we talked to Databricks to understand what should we do. We wanted to re-architect not only our infrastructure, but our data model. So we leveraged a medallion architecture, and if you don't know what medallion architecture is, it is pretty simple. It's a way to handle your data in a simple approach that helps you manage the complexity and improve data quality. So the bronze layer is pretty much a system record, and it's directly from the source, and you're not transforming that at all. You're just ingesting it so you have that data within your ecosystem. And then from there, we go into silver. We apply some business logic, filtering, whatever you need to help your business run. For us, we play in a lot of different categories, so we might have to filter our data down to those categories and put them in different schemas. So we use the silver layer for that as a mechanism, and you'll notice that for the bronze and the silver layer, we're streaming all the way through, so there's continuous updates if it's available. And then finally, we leave the gold layer, which is a curated view, and that is our analytical part. So for us specifically, we use the gold layer as common aggregated data tables to help our performance for querying. We also have a platinum layer that's more specific for us for our curated applications to make sure that our performance for our machine learning and dashboarding is most efficient because our business needs the data now. So what makes it powerful with DLT and this medallion architecture is that we're able to put all this in one DLT pipeline. So you can imagine you're working DLT and you can see this flow within a visual and see when your tables are flowing down into the process. As one of the downstream tables is done, it will start on the next, so it improves performance. Then you don't have to manage all that complexity of refreshing data. And there's no more manual orchestration or the dependency management like I was saying. And it helps your data stay more up to date and resilient with minimal overhead, and it manages for you. At the result, design was scalable, trusted, easy to manage, and it allowed us to use, it was the same across batching and streaming. So this was, once we had the data structure, the next step was giving the team visibility into how our data flows throughout the platform and where it comes from and how it's managed. And that's where lineage and discoverability comes into place. So one of the beautiful things of using some of the Databricks capabilities like DLT, workflows, and Unity Catalog, it gives you this visual of how your data assets are being created. And for us, with the medallion architecture, now we can see the different layers and how they stack up with one another to the final product, which gives us the end-to-end data lineage that we want and the transparency. Not only does it give you it for your table level, it gives you it for your column level. So if you're doing custom business logic or adding aliases and changing table names, it is flowing through your full ecosystem, so you have that visibility. This, for us, has unlocked trust in our data. So as our business users want to explore and understand how their data is being created, they can come in here, see it easy visual, and understand how it flows through our ecosystem. And this helps us have true democratization of our data and our assets within our organization. Teams now have the visibility to understand how our data assets are being built and the tools we're building it, and it gives them more confidence within our data. So data lineage is just one component of it, though, to building trust within our organization. The other aspect that I want to talk about is embedded data quality. This is very critical because if we don't have accurate data, the business isn't going to trust the numbers that we're reporting on. And so historically, if you've ever built custom data quality, it is a pain in the butt. You have to build your pipelines, your data tables, and then build QC checks on top of it, which is very complex and cumbersome, and they don't evolve with your data. And then if you want to capture those metrics, you have to create additional logic to make sure that you can have it stored in a SQL data warehouse and being able to report on it to see how your data is evolving over time. Well, with DLT, that has changed. So we now can define our data quality checks within the DLT pipelines, which help us simplify our data quality checks. These expectations are enforced automatically, so it allows us to have them run every time we run our tables or our pipelines, so we're making sure our data is accurate each time we're running our pipelines through our ecosystem. Also, these metrics are captured automatically without any other engineering effort. So you can see how your data is evolving over time, which is critical, so you can see if the health of your data is going down or up and what is causing it downstream. So for this data quality checks in Databricks, it's usually a closed looped approach. You define the controls, so the business logic that you want to apply, like if the sales can't exceed over 100 billion for one product, that probably isn't right. And then you want to identify and capture those metrics so that you see if there is issues, and then you resolve those issues. So then you can identify also with the medallion architecture, is it a source system issue, or is it us issue with our aggregations or anything else? So it gives you that ability to identify those issues quickly. What this unlocked for us also, it reduced the risk of bad data flowing through our data pipelines and impacting our downstream reporting, our machine learning algorithms, and much more. It gave us earlier detection of the issues before it caused any issues or problems. And just like data lineage, it gives you these expectations within the UI, which is the second visual there below. You can see how your data quality is flowing through your ecosystem and what part has failed or dropped and what percentage of it. There's a lot of different rules you can build into it, so you can build expectations if you want to kick it out or if you want to still include it, but just warn you, you can do a lot of different custom things to help your data quality be improved. And with the expectations and metrics in place, the final piece for this is how we track it and manage it across all of our workspaces, all of our pipelines in one place. And that's where observability comes in. For this, there is kind of two components. So there's the event log for DLT, which is very helpful. You can see the top visual here. It tells you your query history, it gives you all the information of your flow, what data is going through, how's your pipelines running, what tables are created, and pretty much gives you a real-time update. And it also tells you the data quality and everything else on top of it, and the dependencies. So what we needed wasn't just that, though. So we needed something that was more observable, an observability hub for us, because we had a very dynamic and complex ecosystem. And we worked across multiple workspaces because we managed multiple retailers. So with Databricks' help, we co-created with them a observability hub. And that allowed us to have a dashboard within Databricks that helped us observe all of our data workflows and pipelines. It gave us the central location to see how our tables are running, if there's any data quality checks that are being ran, and then also gave us the ability to see how our data is failing or going through, and it gave us the deep dive. You can see that kind of faintly there on the right tab. You can see a root cause analysis of what's breaking and help you see downstream dependencies because of those data quality and lineage capabilities within Databricks. How I think of this and how we kind of thought about the idea is a real-time flight board. And so we wanted the visibility to see how our data is in flight. Is it on time? Is it delayed? Do I have to get a new flight? So being able to see that through this one platform. And also, it enabled us for root cause analysis so that we could trace the issues back to the source and understand those dependencies downstream quickly. And this is about building trust with our data and for our business partners, and allows us to fix issues quickly and more efficiently before it impacts our business and our reporting needs. But that's just about the data visibility, governance. One of the most critical parts for us is the performance optimizations from DLT. On the business team, we need our data now. Our business expects it immediately, and they need it to report to our retail partners. So performance was critical for us. And so when we're talking through Databricks, we were trying to make sure that our performance would meet the business needs. So thanks to DLT, powered optimization, and some other components within Databricks, we leveraged liquid clustering, which is pretty much Z-order and partitioning, automatically managed for you, deletion vectors for change feeds, and predictive I/O. This allowed us to have both faster reads and writes that enabled our pipelines to run faster. And not only that, it allowed our querying to be quicker. So as we were querying our data internally for our applications or the business, it allowed us to have those applications run faster so that we can work with the data more efficiently. This performance also works across both streaming and batching. So we saw the performance gains when we were using both these types of data ingestions. And so we were able to take advantage of this. One other point that really helped us was the serverless compute for 2 instances. One, it allowed us to not have to manage our compute like I was saying earlier. We don't have to manage the resources. And then also, it helped lower infrastructure costs, and it improved our performance overall. One of my favorite things, though, is that I don't have to wait 10 minutes now to start up my cluster. It takes a couple seconds, so I can get to the data more efficiently. So with this, we ended up with faster pipelines, smarter resource use, and a platform that was built to scale with us, no matter how fast our business was moving. But this wasn't the only thing that we wanted to implement to help us deploy the most modernized pipeline. So earlier this year, or late last year actually, Databricks had direct publishing in private preview. Now it's in public preview, but essentially what direct publishing enables is to allow you to publish across multiple schemas or catalogs now in one pipeline. In the past, you would have to use multiple pipelines to write to multiple schemas or catalogs. So it increased engineering efforts and the complexity overall. And so now we don't have to do that. We removed the duplication of our pipelines and the complex routing logic. Like I was talking about earlier, we have that category data, so we had to have multiple pipelines to move that data to the specific categories. And so with this, we don't have to have multiple pipelines. We can use metadata now to drive those pipelines to push our code more efficiently. So we don't have to have less pipelines, less notebooks, making our processes less complex and easier to manage. So the main benefits here, like I was saying, it eliminated our complexity overall for our redundancy and made our system far more maintainable. It was a great example how we used thoughtful design and flexible tools like DLT to turn a burden that used to be in the past when we were using ADF and having to have multiple different pipelines to something more scalable, reusable, and more efficient. But this process was not as easy as it sounds. We did have some challenges and constraints. We found solutions, and then we had insights. So for the constraints, there's some things that you don't expect when you're working with streaming data sets or different technology, but you learn it as you go. So I'll share this, so if you do start working with DLT, you know. PySpark has some limitations with streaming data frames, so you can't use certain functionalities in a streaming table that you can use for normal Spark jobs or materialized views. So we had to re-engineer some of our business logic to handle that. Also, self-joins and full outer joins are not supported for streaming tables because of the computational expenditure when you're trying to join those two tables together. And then also performance issues with large joins. So we manage a vast amount of data, and so large joins with two streaming tables can be very costly. So with those constraints and issues, we had some solutions. So we engineered a custom self-join logic that helped us manage that, because for us, we needed that for our business logic. We had to reintroduce that to make sure that we're meeting our business needs. And then we also had to learn when and how to apply stateless joins. So a stateless join, you could think about it as a delta or a materialized view joining onto a streaming table. It's pretty much a table that isn't refreshed as frequently or continuously onto a streaming table that's always updating. So a dim table to a fact table is how I would think about it. So we had to think through those solutions and make sure our performance was worth it. So that brings us to some insights that we received. So one thing that I found out is when a materialized view actually gets created versus a streaming table, that is interesting because you have to make sure at the base is a streaming table if you want to keep the table being streaming, and you have to join this materialized view or the delta table onto it. You can't have it the other way around, or you'll make the table a materialized view. And so we had to be cautious when we were doing that to make sure that everything we were building was streaming if we wanted it to be. If we wanted it to be materialized view, we flipped the join around. And then we had to tune the architecture for speed, cost, and usability. So looking at all these different challenges we faced and the complexity of our data model, we had to identify what would work for us and how we could optimize it to make sure that we're getting the best for our architecture and driving that business growth. And then lastly, we had memory limitations. So when you're streaming, you're using a lot of memory, and there were some out-of-the-box configurations that we found to when we talked with Databricks. If you do run into some memory issues, you can use a configuration called RocksDB, and that will help with your performance overall. We saw exponential gains when we used that and turned it on, and we had it off, it would either fail or be running for a very long time. So these lessons helped us build a system that was more resilient and what was ready to come up next in the iteration of the next generation of capabilities. So with that said, I want to bring it all together and kind of wrap it up. So our legacy architecture wasn't built for today's demand. It wasn't ready for real-time analytics or real-time data and AI, and not for the volume and the complexity of modern retail data. The result, it was slower insights, higher operational costs, and growing gaps between our business needs and what our platform could deliver. So we made the shift, and we went to serverless, streaming-first architecture, powered by Databricks and DLT, and this enabled us to have real-time analytics at scale, improved our data quality, and led to less cleanup, and also reduced our engineering efforts overall, so we don't have to have that engineering redundancies, and a future-ready foundation for AI and automation. The business impact, which is the most critical part for us as we were rooted in our business goals, we saw an overall 25% reduction in our costs for our infrastructure. So that is our job clusters, our storage, and much more. Not only that, we saw 200 to 500% time savings in our pipelines and our data being processed. That has helped us deliver our data more efficiently to drive that growth. This wasn't just about rebuilding our pipelines, it was about unlocking the speed and flexibility and smarter decision-making across our teams more efficient. With that said, thank you all for coming, and I'll spend some time for Q&A if you have any questions.